Hey everyone, welcome back to the channel. Today, we're taking a closer look at the CNC lathe machine, one of the most powerful tools in the machining world. If you've ever wondered how those perfectly round metal parts are made, this is where the magic happens. We'll walk you through the basic parts of the machine, how it works, and even run a quick demo so you can see it in action. Whether you're new to CNC or just brushing up, you're in the right place. Let's get started. CNC lathes are a type of machine controlled by a computer used to shape materials, usually metal, plastic, or wood, by rotating the workpiece against various cutting tools. CNC stands for Computer Numerical Control, meaning the machine follows precise instructions from a computer program to perform tasks such as cutting, drilling, turning, or threading. CNC lathes are commonly used in manufacturing to produce parts with high precision and uniformity, such as shafts, bolts, and custom components. They improve speed, reduce errors, and allow for complex designs that would be difficult to achieve manually. CNC lathe operations involve a range of precise machining processes used to shape a rotating workpiece. Common operations include turning, which reduces the outer diameter, facing, which creates a flat surface at the end of the part, and drilling, which adds holes into the center. Additional tasks, like boring, refine existing holes, while threading is used to create screw-like patterns on the inside or outside of a part. Grooving adds narrow recesses, and parting or cutting off separates the finished piece from the raw material. All these operations are controlled by computer programming, allowing for high precision, repeatability, and efficiency in manufacturing. To set up a CNC lathe machine, begin by placing the raw material, called the workpiece, into the chuck and tightening it securely so it doesn't move. Then, install the cutting tools needed for the job into the machine's tool holders. Once everything is in place, turn on the machine and let it return to its home position, which is a known starting point. After that, load the correct CNC program into the machine. This is the set of instructions it will follow. You'll also need to tell the machine where the workpiece is by setting the work coordinates and tool positions. Before starting the actual cutting, it's a good idea to run the program without cutting, called a dry run, to make sure everything works smoothly. Always wear safety gear and stay alert while the machine is running, especially during the first few cuts. CNC lathe machines use a programming language called G-code, which controls the machine's movements and functions. G-codes are used to direct positioning, cutting, and shaping, while M-codes handle machine operations like starting or stopping the spindle and coolant. Common commands include G00 for rapid positioning, G01 for linear cutting, M03 to start the spindle, and M30 to end the program. These codes, along with others like tool selection, T, spindle speed, S, and feed rate, F, are written in a sequence to create a complete machining program. The specific format can vary slightly depending on the CNC controller brand, such as Fanuc or Siemens. There are several types of CNC lathe machines, each designed for specific machining needs. The main types include 2-axis CNC Lathe, the most basic type, with X and Z axes for simple turning and facing operations. 3-axis CNC Lathe adds a third axis, often C-axis, to allow for milling, drilling, or tapping while the workpiece is held. Multi-axis CNC Lathe, 4-axis, 5-axis, and more, offers complex machining by combining turning and milling in multiple directions, used for advanced precise components. Swiss-type CNC lathe, specially designed for small, high-precision parts. The material moves through a guide bushing while being machined. Turret. CNC lathe has a rotating tool turret that can hold multiple tools, reducing setup time and increasing efficiency. Vertical CNC lathe, VTL. The spindle is oriented vertically, ideal for large, heavy workpieces like wheels or discs. Slant bed CNC lathe features an angled bed for better chip removal and tool clearance, commonly used in modern CNC setups. Finally, the CNC lathe is not just a mechanical entity. It represents a combination of technology and art. Each part it produces tells a story of precision engineering, where the expertise of the operator meets the capabilities of the machinery. As technology continues to evolve, CNC lathes will certainly adapt, but their fundamental role in manufacturing will not change. They will continue to be the backbone of production, enabling industries to innovate and create with unparalleled accuracy. For anyone entering the machining field, mastering the CNC lathe is not just a skill, but a stepping stone into a world full of endless possibilities. Thank you so much for watching. If you found this video helpful, don't forget to give it a like, subscribe to the channel, and hit the notification bell so you won't miss any future videos. See you in the next one.